some integration by parts problem have one integration by parts inside another integration by parts. So when you perform integration by part, expect to repeat this process 2 to 3 times. And these are the two perfect example. The first one is integral cosine square theta d theta. This has two integration by parts and one infinite loop. The next problem, integral x multiply ln x the whole quantity to the third power dx, has three integration by parts due to this third power. So let's do this problem. So the first one, let's do the cosine. So for the cosine, I'm going to rewrite the function first. So we are going to get an integral cosine theta times cosine of theta and then d theta. This is how the square works, right? And then I'm going to let u equals to cosine of theta, and then du equals to negative sine theta d theta. Just take the derivative, right? And then the dv is everything else, so that is cosine of theta d theta, and then v is equals to, you integrate both sides, so you have integral of cosine theta d theta, and then what is that equals to? That is equals to this is equals to sine of theta. So this is the first integration by parts. That is the steps, and then you have to put them together by doing u times v minus the integral of v du. So let's see, what do we get? We have uv, so that is cosine times sine, so cosine of theta times sine of theta, that is your uv, and then minus the integral of v du. So we have integral v du, so we get a negative sine of theta times sine of theta d theta. And then this one we have sine times cosine. So sine of theta times cosine of theta, minus minus becomes a plus, so you have an integral sine square of theta, or you can leave that as sine times sine. Now, here is the breaking point. There are two ways to handle this. The first way is what I recommend the most, is you will have to recall the trigonometric, the fundamental identities. So which is, so we are going to recall that. So we are going to recall that sine square of theta equals to 1 minus cosine square of theta, and then we are going to do an infinite loop. And other way to do this is, you can do this, you can put an or, so we can put a or, you do this, you let the sine square becomes integral sine theta times sine of theta d theta, and then you do another by parts. But you will have to do an infinite loop at the end. So this one is a loop, you have to know how to do it. So I am going to use the green method. So what I am going to do next is, I am going to let that equals to 1 minus cosine square. Alright, so what I am going to do next is, I am going to follow this color code and then do the jobs right over here. So what we are going to get next is, we are going to get sine times cosine. So let's follow the color code. So we have sine of theta times cosine of theta, and then plus integral 1 minus cosine square theta. All right, so 1 minus cosine square theta d theta. And then what is that equals to? That is equals to, you add integral of 1, right? So this one you add an integral of 1 and then d theta, and then you minus integral cosine square theta d theta. And then the yellow part is from the first integration by parts. So you have sine of theta times cosine of theta, and then as you can see, we just back to the original problem. So do you see that this is the given integral? So back to the given integral. Then this is going to be a loop. So if you just keep doing this, so every time you repeat like 1 or 2 integration by parts, you will get an integral which is equals to the original problem. So the way we handle this is, so here is the infinite loop. So the way we take care of this infinite loop is, we write the problem first. So we have integral cosine square d theta. This is what I gave you. So you say that equals to what I have right over here. So we have sine of theta times cosine of theta plus that one gives you a theta, right? And then you minus integral cosine square theta d theta. Do you see that you have this minus itself? Do you see that? You have that minus itself. That means I can just handle the loop like this. So I'm going to take the minus cosine and then put this back over here. Then what do you get? You have one of this, you plus another one of it, then you get two of this. So therefore, you have 2 times integral cosine square equals 2, and then everything else, then you have sine of theta plus cosine of theta, and then plus theta, right? Oh, actually it's sine times cosine, huh? I wrote sine plus cosine. It's actually sine times cosine and then plus theta, and then you will have to multiply both sides by 1/2. So at the end of the day, you have 1/2 sine of theta times cosine of theta plus theta. So you multiply the whole thing, and then what else do we have to put? We have to put a plus c. So that is what the problem equals to, and then of course we put the problem down right here. So cosine square of theta d theta is equals to this, and then this is my answer. So let's use a perfect box. I'm sure that the Notability will give me a perfect box. Yep, there we go. So that is the first problem. And then the next problem, we will have to do integration by part 3 times. So let's get started. So first, I'm going to match the color code and then copy the problem first. So we have integral x times ln x to the third power and then dx, and then if in case you ask me, hey, can I bring the 3 down? The answer is no. This is ln x. You raise the whatever x is, you ln that, and then you raise the whole answer to the third power. You cannot bring the 3 down. The only case where you can bring the 3 down is you have ln x to the third power. So this, you can bring the 3 down to the front. So that is equals to 3 times ln x, because in this one you pick an x value, you take the third power of that, and then you ln the answer. In that case, you can bring the 3 down, but not in this integral. So what we are going to do first is we are going to let u equals to ln x. Do you still remember what did I say about the integral of ln? When you find the integral of ln, that requires integration by parts. So when you do integration by parts, do not draw what the integral of ln equals to. You have to assume that you don't know what the integral of ln equals to. Okay, so when you see the ln, the only choice is you have to take the derivative of that. You have to let u equals to that. You cannot let dv equals to that. And then du equals to 1 over x and then a dx. You know what? That is not a good option. I will just raise the whole thing to the third power. Okay, let's redo it. I will just raise the whole thing to the third power. And then du equals to dx. Oh, by the way, if you don't want to erase what you have, you can keep going, but I don't think that is going to help. So when you take the derivative of that, you bring this down. So you bring the 3 down, and then you have a second power. By chain rule, the derivative of ln is 1 over x, and then you have a dx. So this is a ln x. Okay, so that is my du, and then what is my dv? My dv is everything else, so that is x dx, and then the v is equals to integral of x dx, that is equals to 1/2 x squared. And then you will reach to your first integration by part, uv minus the integral of v du. So you have your uv. That means you have your x squared divided by 2, right? So you have your x squared divided by 2. You have your ln x to the third power. This is your uv. And then minus the integral of v. That is 1/2 x squared. And then the du has a lot of stuff. So 3 and then ln x squared times 1 over x dx. And then you have to simplify the integrand. So x squared, that is equals to x squared divided by 2, and then you have ln x to the third power, and then minus 3 over 2. Let's pull the constant out, and then the x squared and the 1 over x, that becomes an x, right? So that becomes an x, and then you have ln x squared dx. That is another integration by parts. So this is another integration by parts. So this one is another by parts. What is the difference between this and the given integral? The difference is we just reduce the power by 1. It was 3, now it is 2. We just reduce the power by 1. So it looks like every time we do a by parts, we will reduce the power by 1. So let's keep on moving. And then for the integration by parts, let's do the job right over here. So we have to let u equals to ln x squared, and then du equals to 2 ln x, and then the derivative of ln is 1 over x. Again, you do not know what the integral of ln equals to. And then dv equals to everything else, so you have your x dx, and then v is integral of x dx, so that is equals to 1/2 x squared, and then you have your uv minus the integral of v du, so integral of v du, so your uv is equals to x squared divided by 2 times ln x squared, that is your uv, and then minus the integral of v du, integral of v du, you have your du multiply 2 ln, and then 1 over x dx, and then this is x squared divided by 2 times ln x squared, right? And then minus the 2 and the 1/2 got cancelled, and then this is reduced by 1, so we have a x multiply ln x, right? And then dx. So now we just reduce the power by 1. We've just reduced the power by 1, and then we have to do another integration by parts. So this is another integration by parts. Now, what I suggest you to do is you write what you have so far. So after 2 integration by parts, this is what we have. So let me just write this down, and then of course I will follow the color code. So after 2 integration by parts, let me match this color code. So after 2 integration by parts, I will just call this by parts. What do we have? We have to start at this line right here. We have to start right over here. So we have x squared divided by 2, and then ln x to the 3rd power, right? And then we minus 3 over 2, and then we have the blue by parts. So let's use a square bracket for that. So let's follow the color code, and then we have that multiply x squared divided by 2, and then you have your ln x squared minus integral x times ln x dx. Right? We just pull this part down right here. And then where is the last by part? The last by part is right over here. So it's right over here. So we have another by parts. So this is our 3rd integration by parts. You have to let u equals to ln x. Again, you don't know what the integral of ln equals to. Du, and then your dv equals to everything else, x dx, and then v is integral of that, x dx, that is equals to 1/2 x squared. Okay, you are doing fine, right? So you have to do uv minus v du. So uv minus the integral of v du, then you have x squared divided by u divided by 2, and then v is uv, and then times ln x minus integral of v du, integral of v du, so v is 1/2 x squared, du is 1 over x dx, so it looks easy. This is a x squared divided by 2 minus ln x, and then you subtract. So you have a 1/2, and then this is an integral of x, right? So that gives you a 1/2 x squared, and then you change the 1/2 times 1/2. I don't want to spend another line for this. I will just change that to a 1 over 4. So this is the result of the 3rd integration by parts, and then you have to subtract this. So look, you have a minus here, right? So you will have to subtract the whole thing. Okay, so what is the final answer? The very last step. The very last step is after we did in 3 copies of integration by parts. So we have x squared. Okay, we should match the color code, right? So we have x squared divided by 2 times ln x to the 3rd minus, you have a 3 over 2 times that. So 3 over 2 times this. So I'm looking at this. You have 3 over 2 times that, which is 3 over 4 x squared, right? Then that gives you a 3 over 4, and then x squared. Which color should I use? X squared, and then ln x squared, and then you will have to take a 3 over 2 minus 3 over 2. You put that right over here. Okay, should I just do this in 2 lines? I think I would just have to do this in 2 lines because I don't want to take any chances. So what happened when you multiply this? So when you distribute the minus, you have a minus x squared over 2 ln x, and then minus minus becomes a plus 1 over 4 x squared, and then you distribute the 3 over 2. Whew. Okay, so what do we have? The last line we have a plus x3 x squared divided by 4, and then ln x, am I right? And then a minus 3 over 8, and then you have an x squared, and then you plus up xc. And then for the rest, we will just fill out the blanks. So you have x squared divided by 2 ln x to the third power minus 3 over 4. You have x squared times ln x squared. And then, yep, I guess that's it. So the last line, this is your final answer. Yep, so x squared divided by that, ln to the third, so 3 over 4x squared ln x squared, and then minus, yep, everything looks good to me. So plus 3 4x squared ln x, yep, everything looks good. Okay, so that is the end of this video. If you like the problem I create, you like the way I explain integration by parts, give me a thumbs up, give me a subscribe. I still remember this problem from my integral calculus class, because when you study for exams, you only have like 50 minutes or 90 minutes to take the exam. You want to be fast, you want to be accurate, you want to be smooth, right? So what I suggest you to do is, I suggest you to change the third power to a fourth power, and then do a little practice. And after that, you change the x to an x squared to do a little to do a practice. Make sure you can do it fast, you can do it right, and you can do it smooth. All right, so that's it for this video. I will see you all in the next one. Signing out.